New topic today called we're going to still deal with line segments. All right, I promise you no new vocab, but we are going to still use line segments and deal with them, finding the lengths of them on a piece of graph paper. No ruler needed. All right, how to find the length of a line segment on graph paper. So first thing I need you to do here, part A, can you guys draw me AB on this graph, which you know coordinate A and B now, coordinate A and B. So graph line segment AB for me. All right, we have a graph. Now take a look at part B, please. Somebody remind me, yesterday we talked when I dropped the line segment symbol. What am I now referring to about this line segment? I just dropped the line segment symbol. So now what am I asking about? The length, right, everyone? We're asking for the length of AB. All right, so length of AB. And I'm not looking for anything fancy here, right? We can count the number of units from A to B, B to A, and that'll be the length of AB. So that's what I'm asking for when I drop that line segment symbol. What's the length of AB? And length of AB, because everybody can count. You're in honors class. Odin, what do you have? What's the length? 5 units. All right, we're all good there. Let's try it one more time with a different segment, CD. So everyone go ahead and graph CD, part C. Line segment CD. Bless you. Okay, again, part D. Notice I dropped the line segment symbol. So now I'm looking for the length of CD, and hopefully everybody can count there. And the length of CD by counting. 8 gauge, what do you have? 3 units. Good work. All right, this is nice and fun. That'd be great if that was all today. Just go and graph. But we are going to run into a problem because will all our line segments just be horizontal and vertical? Probably not. All right, so what if it's not horizontal or vertical? That's our topic for today. So go to the next problem now. EF, line segment EF. And go ahead and graph EF. And you'll see a problem right away. And our problem, can't count it. Everyone in agreement, I can't count it. We're not going to go, oh, there's 1, 2, 3. That's maybe a quarter of a unit. No, we don't do that. All right, I can't count that. It's not horizontal or vertical. So we need something else to find the length. I'm going to give you 2 options right now. 2. First option is a formula called the distance formula, which will find the length of any line segment. All right, so down here, distance formula. I'm going to give you a formula that we can use going forward all year long, that if you want to find the length of any line segment, we can use this distance formula. So D for distance equals, and now I got a big square root, which we're going to put some terms underneath. So big radical square root, whatever you refer to it as. All right, first thing underneath this square root is a set of parentheses. Inside those parentheses, we are going to put, and I'll explain what it means in a second, x. Now I'm going to put the number 1, but notice I'm putting it at the bottom, not as an exponent. It's called the subscript, minus x2 at the bottom, not x squared, x2. Now, what does that represent? Your 2x coordinates. That's what that represents. You're going to subtract your 2x coordinates. I'm not done yet, and we're going to square whatever that is. When I subtract it, we're going to square that value. Plus another set of parentheses. And being an honors level here, wild guess what I'm going to put in here. Subtract your y's now, right? y1 minus y2 all squared. And this is all underneath the radical. So you subtract your x's, square them, subtract your y's, square them. First question I usually get, and I got it second period when I did this, am I giving you this formula? Here's an easy answer. What class are you in? Yeah, so no, I'm not. Okay, it's not given to you. It's your responsibility. I will just a quick heads up, doing this for 20 years, biggest mistake kids make are mixing up these signs. Okay, that's the biggest mistake. So try to keep it straight when you use the distance formula. All right, so let's go back up and use the distance. Don't say, I have another version that I know some of you are probably thinking about. All right, let me, is that where you're going to ask?
Yeah.
Okay, let me do distance formula first, and I'll give you option 2, which a couple of you already are starting to think about, which is good. So let's use the distance formula on EF here. So length of EF equals, here we go, big square root. First thing we're going to do is subtract the x coordinates. So give me the x coordinates on E and F. What are the x coordinates on E and F? 6, where are we going? Lucy, x coordinates?
2 and 4.
2 and 4. All right, now good news. Order doesn't matter. Because when you do 2 minus 4 squared, it's the same value as 4 minus 2 squared. Same value. So however you want to do it. 2 minus 4 squared or 4 minus 2. It's the same answer. Check it on your calculator if you don't believe me. Plus, now how about the y coordinate squared? 10, 10. Scott, what's my y coordinates?
1 minus 5.
1 minus 5, or you could go 5 minus 1, doesn't matter. And that's really all you need to show me is the substitution. Because I know right now you're going to go to your calculator and type that all in one swoop. So square root, put them all underneath. We just got to talk about your answer here at the end. So as you type it in and hit enter, your calculator should be giving you 2 different answers, a decimal answer and a radical answer, correct?
Yes.
Pay attention to the directions. Got to pay attention. You can't just pick which one you want, round it yourself, whatever. I want simplest radical form. So I want that radical answer, which most of you should have on your calculator. What are you looking at right there? Let's go, Tess. What are you looking at?
2 radical 5.
2 radical 5. Can you get that on your calculator? And not somebody in your groups? We're good? Just pay attention to the directions. The directions may change nearest tenth. And then you got to take that decimal and round it. So please pay attention to the directions. So EF has a length of 2 radical 5 units. All right, let's talk about a second version of how to do this problem. Maybe you're not really feeling memorizing a formula. You're nervous, you're going to forget something, or just screw it up. All right, there is another way, which you learned last year, and you probably don't see it yet. Zach, you were about to chime in with something. Go ahead. Oh, I thought, no? I thought you were, before I used distance formula, you were going to chime in with a different method. No?
Oh, wait, is it slope?
Well, slope gives me the slope, but it won't give me the distance.
Oh, shoot.
If you do rise over run, that'll give me the slope, right? It won't give me how long it is, though. Okay, but we're going to do something related to the slope, though. Violet, you guys do this last year? A squared plus B squared equals C squared? Yeah, you did, but if you remember, you could only use that on what type of triangle? What type of triangles did you use A squared plus? A right triangle. Make one. Right? Make one. You have the hypotenuse already. Draw a vertical line down and a horizontal line over. You have a right triangle. Not only that, those two, that horizontal and vertical line you just drew in, you can find that you already know how long they are. Count it. Right? What do I have here? 1, 2, 3, 4. 1, 2. Now plug it into Pythagorean theorem to find your hypotenuse. Real quick review here. I can't go into depth about it. We don't have time. A and B are what are called the legs of the right triangle. That's the sides that form the right angle. So that would be 2 and 4 for us. 2 squared plus 4 squared equals C is your hypotenuse, what we're looking for. Keep going. 4 and 16. Make sure you add those numbers first. So that gives you 20. And then anybody remember how to get rid of the squared so I can get c by itself? What do you got, Gage?
Just square root.
Square root both sides. And then as you type in the square root of 20, you're going to see a pretty familiar answer. I'm never going to tell you how to find the distance. All right, that's up to you. I will warn you though, I wouldn't get too comfortable using Pythag all the time because one, you always need graph paper to graph it and see the triangle and count. All right, how many units it is. So you always need graph paper. And two, we're going to be doing problems where the coordinates are not whole numbers. They might have decimals in them, or they might be very, very large, where maybe you don't want to graph 12,000, 5,000. All right, so I'm just giving you a heads up. I have no problem with you guys using Pythag, but sometimes it's not convenient. All right. Any questions, comments, concerns about how to find the length of a line segment now? All right, one doesn't make you great. Let's keep going. And let's find the distance of RS now in simplest radical form. Simplest radical form. Again, I could use Pythag, but you know what? I'm going to need a little extra sheet of graph paper next to me to graph it and draw that triangle in. I'm going to always do distance with you because that's what I'm trying to teach you here today. So let me do distance formula first. Just keep in mind, if you're using the distance formula, I won't provide it on Monday's quiz. All right, first step, subtract your x coordinates. What are the x coordinates up here? I made it a little bit tougher here. Gauge x coordinates.
-2 and 6.
Okay, just be careful of the signs. Last problem, they were all positive coordinates. Now you're starting to deal with negative, so be careful, please. Order doesn't matter. So I'm going to go -2 minus 6 all squared. Plus, how about those y coordinates? 10. Where am I going with that? Scotty, back to you. Where are you going with the y coordinates?
6 plus 2.
Okay, you got to notice that, right? 6 plus 2, or you write 6 minus -2. All right, don't drop a sign. So 6 plus 2 all squared, or just do -2 minus 6 if you're worried about the signs. And now it just becomes calculator and paying attention to the directions. You guys got it made with these calculators. Do everything for you. You can leave it in simplest radical form. When you have the simplest form, let me know. Catherine, when you're ready. Good work. 8 square root of 2. Okay. All right, any issues? Yes.
On like the quiz or test, would you want us to show like the step of like once you have like all of like the x and y value? Like
I need to at least see the substitution. Okay? I want to at least see what numbers you substituted in. We ready to move on? All right, enough of the basic problems, right? Let's apply this now. Little word problem action for the first time this year. Ben and Kate. Let's just say after reading this problem, I think Ben and Kate have a little bit too much free time on their hands, huh? They decide to make a map of their neighborhood. That's cool, huh? That's fun. Anybody ever do that? Maybe I shouldn't really bust on Ben and Kate if somebody's made a map of their neighborhood. Okay, good. You don't have to leave then. Every unit on the graph paper is 100 yards. All right, how many yards away are their houses? First thing I'm probably going to need to know is what's the coordinate of Ben and Kate's house, right? So I can start this journey. All right, I'm going to ask one person the coordinate for each. So I need the coordinate for Ben and Kate's house. Let's see, who's up here? Lucy, how about Ben's house? What do you got there?
Hold on.
Yep, count them up.
6, 2.
6, 2. Count them up for Kate's house and let me know.
Me too.
Yeah, let's roll.
Sorry.
Let's roll, stud.
Negative. Wait, hold on. -2, -4.
You got it. All right, so we got the coordinates. Now, here's the thing, though. I don't want to tell you just to do it one way and one way only. There's a couple options we have, don't we? And I'm not talking about Pythag versus distance. That's your choice. I'm talking about, every unit is 100 yards away. So right away, we could convert these coordinates into hundreds, right? If it's instead of 6, 2, let's do 600, 200 and find the distance. Or, if you prefer, let's find the distance right now between them using just those coordinates, and then we can multiply by the 100 yards at the end. Your call. I'm going to let you do you. All right, I won't call on anybody here. All right, so you figure out what you want to do. Do you want to find the distance, then apply the 100 yards, or apply the 100 yards first, then find the distance? Okay? Or use Pythag. We don't have to use the distance formula, remember? Whatever's easiest for you. You do you, guys. Whatever's comfortable. That's what's good about this course. A lot of times you have options. I'm going to do it my way up here. Okay, looking good. Any questions? They're 10 units away or 1,000 yards. Any problems figuring that out? Similar stuff coming on the quiz. I'm probably not just going to ask a straight distance formula on an honors quiz. I'll apply it like this. All right. Again, we are in an honors level course, correct? All right. I will let you know I also teach 2 classes of what's called geometry A2B. All right. This is where I stop today's notes for that. All right. As you can see, you guys have one more problem. This is where I distinguish between the AB and the BC honors level now. All right. Is a problem like this. Obviously, tests and quizzes are more challenging. So if anybody ever asks what's the difference between an AB and a BC, here it is right here. We do a little bit more challenging problems in our notes along with the tests and quizzes. So here you go. Let's see what you got on here. And you'll have a homework problem similar to it tonight. So determine the values of n. Here's coordinate P. Here's coordinate Q. Quick question for anybody before we even start. What am I telling you there? We should know our notation now, right? We should know our notation. What am I telling you? PQ equals 13. PQ equals 13. Abigail, what am I saying? The length of PQ equals 13. So I'm already giving you the length. I'm not asking you to find it. I'm giving you the length, and I'm looking for the value of n here, or values of n. So this, everyone all right? It's going to be distance formula. I can't really use Pythag here, unfortunately. So let me get out the distance formula. Maybe you guys can help me substitute in some stuff. X1 minus X2 squared. Now, for the first time in this class, where's that 13 going to go? You guys, everyone was like, it's the length, it's the length. Tess, where's the 13 going? Yeah, for the distance. Now I'm going to plug in, oh, I know the distance is 13. Here's where it's going to get, there's going to be some serious algebra coming in here. So sorry if you struggled last year. There's going to be some serious algebra coming in. Give me the x coordinates. X coordinates I want to plug in here. Tess, back to you. What are my x coordinates of P and Q?
3n and 4.
Okay, and remember, I said order didn't matter, but I'm going to make it pretty convenient for me. I'm going to do 4n minus 3n, right? Because I want to deal with a positive n and not a negative one. So I'm going to do 4n minus 3n squared because I have that ability. Order doesn't matter. Whoa! All right. I'm making sure everyone's on the same page because it's going to get nuts right now. Everyone ready? Hopefully you didn't go ahead here. You might have missed something. Okay, just give me the y coordinates. Just the y coordinates. That's all I want. What are the y coordinates up there? Where are we going? Violet, what are my y coordinates?
N minus 7 and n plus 5.
Okay, everybody ready? N minus 7 minus n plus 5. I just did something wrong. It's one y coordinate minus the entire other y coordinate, correct, in distance formula? If I just write minus n plus 5, what's the only thing I'm subtracting? The n. I'm not subtracting the whole y coordinate. It's the whole y coordinate of one minus the whole y coordinate of the other. So n minus 7 minus that entire y coordinate. Make sense? Because if you just write it without that, you're just subtracting n. You didn't do anything with the 5. Make sense? Why I had to do that? You have to subtract the entire y coordinate, just not one part of it. All right, let's clean this sucker up. Is there any questions before we clean it up? Because we're not even halfway done with the algebra part yet. All right, underneath this first one, 4n minus 3n. And then I square it. Okay, everyone's all right. N squared here. Ooh, let's clean this up here. I'm going to go step by step. Don't try not to get ahead of me here. What am I supposed to do here with that subtraction sign? Distribute it, right? Because now n minus 7 minus n, it shouldn't be plus 5 like we originally left it. It should be, yeah, minus 5. Let's keep cleaning it up. Let's clean up that parenthesis. I got n squared. Look inside. Let's clean it up. What happens to the n's? See ya! They're gone, right? N minus n. They're gone. And then I have what? Negative 12. Square it. Well, anytime you square a negative number, you get a positive number, right? So negative 12. Everyone good? Squared. 144. And remember, what am I solving for again? Trying to solve for what? N. Got to get n by itself somehow. Got to get n by itself. Ooh. I know what you want to do, and I'm going to crush your dreams. I'm sorry. I know what you want to think. You think you know what to do next, but I'm going to crush your dreams. I'm sorry. What do you want to do next?
You square both sides.
Oh. That is what I should do. That's not what I thought people were going to say. I thought people were going to say, this is going to turn into n plus 12 because you take the square root. That's what I thought people, square root of n squared is n, square root of 144 is 12. People were going to say, you can't do that. Okay, you can't take the square root of this and get n plus 12. You do take the square, you square both sides. Okay, got to square both sides. Get rid of the radical. Square both sides. Yes. 13 squared, $1.69, right? And what happens here? Oh, just the radical drops, right? Nothing else happens. You're just canceling out the square root. You get n squared plus 144. Welcome to the honors level. Then what?
You subtract 145.
Subtract 144. You get a nice little perfect, literally, number. 25. Anybody get that one? Now what?
Square.
Five.
5. Over a perfect number.
Nope. Nope.
Oh, no, it's 5, right?
Plus or minus 5.
What happens when you take the square root of a number? You get the positive version and the, and most of the time you don't even talk about the negative because it doesn't make sense in a problem. Like you can't have a negative 5 feet, but we're talking about what here? Coordinates, aren't we? Can you have a negative coordinate, X or Y coordinate? Absolutely. Absolutely. So you better have both plus and minus version here. There's no reason to get rid of it. You guys used to this symbol? I can do that. That's all right. I don't have to write both out, plus or minus 5. Yep. So be careful. Yeah, we can have a negative 5 as an X or Y coordinate. Absolutely. Woo! How about that? Welcome to honors geometry. Your first little taste of an honors level here. That is similar to what you're going to have to do on number 64. Whoa, I always know what happens here. Kids come to class and they freak out because it's, well, that wasn't like the one we did in class. I don't know how to do it. Here's why. Just so we're good here with our algebra, you're going to get something that looks like this on that last problem tonight. That's not 2n squared. That is not equal to this. So please don't write that tonight because you're going to get the wrong answer. That is not equal to 2n squared. Anybody know how to deal with that from last year? Your exponent rules? What do we got, Gage?
4n squared.
2 squared and n squared. So that's what happens. All right. So please don't write 2n all squared. All right. 4n squared. Please take a look at all the hints and directions I have at the bottom so you know where to go. Okay. Please take a look so there's no confusion tonight. 64, number 64 is just similar to what we did up here. Okay. Great. Start going. I gave you guys more than enough time today. Shortened class here. We'll see. All right, here it is. Here's the new thing. The only new thing I need to show you today is when you are dividing. Anybody know what you have to do when you divide?
Subtract.
Subtract.
Yeah.
The exponent up top.
Oh, you're thinking exponent. Okay, all right. You got me there.
Is it like the
Got me there.
opposites?
When you subtract, when you divide, it turns into a multiplication problem. Okay? When you divide fractions only, when you divide fractions, you keep the first fraction the same. So let's rewrite the first fraction. Don't factor yet either. Don't get ahead of me. Don't start factoring. We see a squared there. How many times is that happening? Twice. So I always have you guys write it out twice. Y minus 3 and y minus 3. I know you want to factor that bottom one, but wait. Just rewrite it. The division turns into multiplication, and you flip the second fraction. I don't know if you've ever, keep, change, flip.
I remember that, yeah.
Something maybe along that, some teacher along your mathematical career gave you some fancy phrase to remember. All right, I do keep, change, flip. Skip and flip is another one I've heard. So before you start factoring, and it's a division problem, you keep the first fraction the same, flip the second, and make sure now it's multiplication, and we're into yesterday. This is yesterday now.
Yeah.
That's the only thing I need to show you is what to do before you start factoring. All right, real quickly, speaking of yesterday, y minus 3, y minus 3. What do you got on the bottom there?
Y plus 3, y minus 3.
Difference of two perfect squares. Y plus 3 and y minus 3. Can't do anything with that y plus 3. Anybody want to do anything with 3y minus 9?
Take out the 3.
Take out a GCF of 3, and you're left with
Y minus
y minus 3. And now it's time to cross out, right? Top and the bottom. Let's see here. Let's take our time here because it looks like I got a lot to cross out. So at least a set of y minus 3s can go. Looks like the other set of y minus 3s can go as well, right? There's no opposites here. Don't try to pull that on me. And anything else?
Y plus 3.
The y plus 3s can go.
You just write 0.
Whoa!
There's a
No!
three, buddy.
Whoa! Good thing we're talking about
Oh, I didn't see it.
this. Good thing we're talking about this.
Never mind, bro. That's not my fault.
Is anything left on the top?
No.
One.
No, but there is.
One.
You got to put a 1 there. Nothing. You've crossed everything out in the numerator. There's a 1 there, and then what's left at the bottom?
Drop the whole problem.
A 3. 1/3. So make sure you remember if everything's crossed out on top, there's still a 1 there. Anything I can answer there? Go in. All right, that's all I got to show you. Now it's just can you factor for me?
All
right, we ready?
Yeah.
Get called on. All right. Again, I don't recommend it, guys. Just rewrite it first before you. I know some of you want to start factoring right away. Just rewrite it because you might forget to flip. So it's division. I change it to multiplication. I flip it. Keep, change, flip. Okay, here we go. Let me know what you want to factor, all right? Let me know what you want to factor. Shoom, not here today. Next one. Amber, what do you want to factor? Because you can factor all of them.
The bottom left.
Bottom left, what do you want to take out? You want to take out I'm just going to take out a 3. Is that all right? So take out a 3. You can take out a -3. That still works. And what are you going to be left with if I take out a 3 here?
3 minus 8.
Okay, good work. All right, let's keep going. What else you want to factor? 2. Marat, what do you got?
I'll do bottom right.
Bottom right, you got it. 2 numbers that multiply to 6 and add to 5.
6 and 1.
6 and 1, they add to 7 though.
Oh,
So
They do multiply to 6, but they're not going to add to 5.
is it 6 and -1? Oh wait, nah. I gotta think about this one for a second.
Numbers that multiply to 6.
3 and 3. 3 and 2.
3 and 2, can you get a 5 from those?
Yeah.
What's the signs? A,
Squared. Oh, okay. A plus 3 and A plus 2.
you good?
Yeah. I was thinking. So that's good.
All right, what else? What else here do we want to factor? What else? Keep going here for me. Hav, what do you got?
These are top one.
Sure.
A plus 3 and A minus 3.
All right, you got it. Difference of 2 perfect squares. And then somebody's got top right for me. 6A and the 12 there. Max, what do you want to do?
Take out the 6.
Darn right you will. And what are you left with?
A plus 2.
All right.
Yeah, that's very much.
All right, let's start crossing out everything that's the exact same because we do have a little something going on here. A plus 2s are gone. Plus 3s are gone.
Yeah, reciprocals. No, we don't.
Yes, we do.
A minus
Yes,
3.
we do.
Now we have opposites, don't we?
And then one.
Is this remember how to check? Positive A, negative A. -3, positive 3. Up, they're both all opposites. So yep, cross them out. But
-1.
I'm left with a -1 somewhere. All right, some of you may see it, even if you don't. That's fine. If you see this coming up here, what's left on top?
-6.
-6, and on the bottom.
3.
So even if you didn't see it at the cross out step, hopefully now you do. We're not leaving it like that in this class.
-2.
-2, final answer.
Easy.
So far. Anything I can answer here? Oh, how about 3? Oh, we're getting a little nervous now.
I'm not nervous. I'm nervous.
Oh, I've never seen anything like
Still
that
get
before. Relax. Hey, what's that a fancy symbol for?
Division.
Yeah, it's a division, right? fraction bar. That's all it is. Yeah, if you're nervous, right, Tyler? If you're nervous, just rewrite it with the division sign in there. Okay, so ready? Keeping the top. Top's not changing. 15x to the fourth, y to the 15th over. Change it into multiplication and do what to that bottom fraction? Flip it, yeah. Again, if you don't like, hey, does everyone see what I mean? It's this divided by this. That's just a fancy way of me writing it. So the 30xz goes on top. 10x to the third y squared. All right, I'm glad we're doing this again. Is there anything to factor? Is there anything to factor? No, there's no pluses or minuses in between. Nothing to factor. And I prefer you not to start crossing out because it may look like a hot mess. All right, so what I would do is numerator times numerator, denominator times denominator, like I showed you yesterday. So multiply everything in the 15 times 30. That's a large number right there, huh? Was that 300, 150, 450? God's human calculator. Yep, 450. How many x's?
5.
5. So x to the. Is everyone all right? Stop me if you don't see where this is coming from. I got 4 here, 1 here.
X to the
5. 5. How many y's?
15.
15. And how many z's?
1.
Just a z, yep. On the bottom, I got 25 times 10. Throw a little 0 in front of that 25, right? 250. How many x's? 4. How many y's?
3.
3, yep. And then z's? 1. And remember, your calculator will reduce those numbers 450 over 250 for you, right? It'll reduce that for you. And then you guys got to take care of the x's, y's, and z's. Oh, what's that going to be? The zeros go 9/5. 9/5.
Yeah. Pretty good at that.
That's what they tell me. How many x's?
1
Where?
next to the X.
See what
Next to the 9.
Yeah, you
In the numerator. Thanks. Let's use our vocab. How many y's? 12. Where? Numerator. Z's.
0.
See ya. They cancel. All right, we're good. Keep moving on because I'm trying to have a lot of time for you guys to work today. All right, I'm just, again, I don't want to touch anything until I rewrite it. I see division, keep, change, flip, skip and flip. Okay, let's get, I don't like those parentheses being there. Oh, sorry, one job. Multiplication. We've only done one in this class so far this year. Anybody remember how I deal with this?
4x squared.
Take the 2 squared, x squared, right? 4x squared. If you give me 9y cubed, get out of here. 3 to the third is not 9.
27.
Killing me. Right, Tyler? Have some self-respect. Right? It's up to you what you want to do. I probably wouldn't cross out. First, is there anything to factor? I should have asked that.
No.
Anything to factor up there? Nope. You can cross out if you want, but I would probably turn it into like this previous problem because you guys know how to do those a heck of a lot better than trying to cross out a top and a bottom here. All right, so nothing to factor. What am I left with on top? Let's see if you guys got this down here. 12x squared y to the third, or cubed. I like the fancy way there. Nice. Yeah. showing on. 27 times 2, what's on the bottom now?
54 x squared.
Ooh, oh. X's and Y's, see you later, huh?
See you.
What's 12 over 50? Ooh, boy, that's going to challenge me right there. I'm going to guess a 3. So that's maybe a 4. No, 6.
A little bit.
2 ninths.
Yeah.
Yep.
2 ninths. 2 ninths.
Good at math.
We should probably be a teacher.
Anything else?
No.
All right, I really don't want to keep harping on all these, so why don't we just go to one diesel level problem here? Anybody got a preference? Looks pretty intimidating.
Let's do
5, 6,
seven.
or 7?
7.
Let's do 7.
Because it's the last one and it should be the toughest. Is that what the thinking is?
It just looks the hardest.
It does. I thought people were going to pick 6. That's a lot of 8.
Five is the hardest.
We already did number one like
5
6.
looks the hardest.
That looks pretty intimidating.
6 is pretty
7.
light. I can do that in my head.
Let's do 7. There's only X and 7.
Why not all?
Because you got numbers in front of you.
I can do like 6 in my head though. So
We're doing 7.
Yeah.
That's grouping. That's
7.
Yeah.
All right, here we go. Skip and flip first for me. I don't even want to talk factoring. Skip and flip.
Are we speed running this?
I think I'm
I'm doing it.
It looks like I'm going to have 2 groupings and a GCF here. Because 4x cubed we're not touching. So it looks like 2 groupings and a GCF. All right, so let's this first. Can we just talk quickly that top left? How I know it's grouping instead of me just saying it. No, whoa!
No
Where do you
GCF.
start first?
No GCF.
No GCF. How many terms?
3.
And what's the number out in front?
2.
2. So you can't go multiply to 5 and add to 11. Can't be doing that. So I'll go up here. I'll review that quick because I know grouping is probably the toughest one for everybody. How many terms are here again? 3, and we got to turn it into 4 terms. And it's only the middle one we worry about. It's only the middle term. Everything else stays the same. What's the first step? Multiply the 2 and the 5 to get 10. Now what are you thinking about? What are you going to put in the blanks here? Numbers that multiply to 10, but should still give me 11 in there, right? Multiply to 10, so 2 and 5. That's certainly not going to give me 11. My only other option, 10 and 1. How do I get an 11? Plus 10 plus x. And ask now. Ask because you're going to have to group on Tuesday's quiz, definitely. And you're going to have to group the bottom one here, too. All right, group them up. First and last. First 2, last 2. What is everyone taking out of the first grouping?
2x.
A 2x. And we should be left with x plus 5. Remember, you have to be left with an x plus 5 or you never could have grouped it. And what are you going to take out here then? Yeah, you can add, if whatever is in the parentheses is the same as what you need, you just take out a 1 and it doesn't change it. And then you have one more step, which is finish the grouping. 2x plus 1, x plus 5. All right, I'm going to leave you to group that last one here. Let's see what you have.
X over 2x plus 1.
Because there's 2x one down here.
Yeah, you have 2 of those.
Yes, you
I
cross
had
them out, what's
2.
left?
I had
X
2.
plus one.
I had 2x plus 1s. Hold up.
This one, right? It's x plus 2 x 2, then you group. You get a 2x, you get x plus 1. 1.
It's 2x
Oh, it's
plus
2x
2.
plus 2. Oh, yeah.
It's 2x plus 2.
2x plus 2. Yeah.
Two of that.
Yeah.
Two X.
Two.
Minus 50 still points.
Shit.
I go 7.
When you group that bottom left, we should end up with 2x plus 1 times 2x plus 1. When you group the bottom left.
It's just my mindset.
And then we should be taking a GCF out of the bottom right. Taking out a 2x squared. Then we should have x plus 5 here.
Where is cube? Cross.
I don't want to talk about crossing out yet. I want to make sure everyone's good on the factoring part. Let me know if the bottom left or the bottom right you want to see factored. Anybody all right on the factoring? All right, when you cross out, you can only cross out one on one here. It's not like I can get rid of all 3 of these 2x plus 1s. It's 1 for 1. One numerator with 1 denominator. So those are the only 2 I can cross out. I can't get rid of all 3. Looks like what else do I have in common? X plus 5s. And now let's say you don't see it right now. There is something else to cross out, but maybe you don't see it. All right, no problem. Let's rewrite. Let's see. I look on the top, and I'm left with a 4x to the 3rd. All right, over the bottom, I got this 2x squared, and I still have a 2x plus 1 here. Now, hopefully you see it. You might not have seen it in the cross-out step, but maybe you see it here now that you can cross out. 4 and 2, right? 4 over 2 reduces to 2. And then how many x's do I have on top?
3.
On the bottom?
2.
So they both eliminate, and how many am I left with, and where?
2x on top.
And one of them on top, right? This is a good one, too. I'm going to get you guys all fired up. What's left on top?
2x. 2x.
Bottom?
Cross out.
Don't tell me we can cross over 2x.
So I want to argue with you. I want you guys to argue with each. I want to argue with each other. Do I box this in,
You box that in.
or do I cross out the 2 x's
Hold on,
there?
hold on, let me think.
I'm putting all my stuff across
Yeah.
the line.
No,
Do
no,
I
because
box
it's
it in,
2x plus 1.
Or do
not
I
just
throw
2x.
in the
It's got
cross
the
out
one
the
and
2
two
Box
x's?
it, box it. Lock it in.
All my stuff points on
Cross.
the
Cross out.
I'm throwing in all my points.
All my
I'm
stuff
cross.
points on
I'm
the table.
gambling.
Cross out.
No, because it's
Box
plus
that in.
1.
It's addition.
Come on, go all in.
That
All in
doesn't
on
matter.
points.
It's 2x plus 1. That means that you're adding something to it. That means it's the one on top.
This 2x
It's
is attached
Yeah.
to the 1, right? You can't cross out 1 without crossing out the other one, and I cannot cross out a 2x and a 1.
Points we get.
We just doubled our stuff points.
That's a blackjack.
That's what we're left with. Okay?
That's what I said.
It's attached to the 1. It is attached to the 1. You cannot cross it out when there's plus and minuses. All right?
Good luck.
All right, I've talked enough here. Get going on the next page with those division problems. Let me know if you have questions, especially the factoring part. I do not mind sitting down with you to help you factor.